Section 3.4 involves function notation. When we write f of x, this is pronounced f of x. Do not say f times x. This means x is a function of x. X is the value that we are going to use. That's our input. And whatever that gives us is the output. Whatever the evaluation of x inside the function f yields, that's the output. In example 1, we have f of x equals x plus 17, and I want to find f of 35. What does this tell me? It tells me I need to plug in x equals 35 into the original function. So let's plug a 35 into that x. To write this properly, you must write f of 35 first, then you can do the substitution. Let's replace that x with a 35 and then add 17. We can simplify 35 plus 17. That's going to give us 52. And that's it. That's all we have to do. When you write your solution, make sure you write it as f of 35, put an equal sign, and then the next line underneath that, there's another equal sign until you get to the end. This is f of 35 equals 52. And that's it. We don't need to solve for x. We just substitute and evaluate. In example 2, I want to find f of 24. Again, always write f of 24. Then you can replace that x with that 24. This is f of 24 equals negative 3 over 4 times 24 plus 15. And then I could reduce. I could put the 24 over 1 and we could reduce diagonally. 4 divided by 4 is 1. 24 divided by 4 is 6. Then we can multiply across. Negative 3 times 6 is negative 18. And then bring down that positive 15. Negative 18 plus 15 is negative 3. And that's our solution. F of 24 equals negative 3. Notice on the left side we write f of 24 only once, and then we have equal signs until we reach the end. We don't need to copy f of 24 3 times. Just write it once. It's not necessary to copy it over and over. In this example, we're going to substitute x plus h into everywhere we see an x. Now, it's the same thing as plugging in a number. It's just plugging in a letter this time. Write f of x plus h. That's what we're plugging into the x. We're replacing that x with an x plus h. And then when I do the substitution here, I'm extra careful making sure I put my parentheses around the x plus h. Then we can subtract 35. We have to distribute first to simplify. 8 times x is 8x. 8 times h, well, that's 8h minus 35. Stop here. We're done. Do not collect like terms because there is no like terms. This is the simplest we can make this expression. We're done with the problem. So it doesn't matter what you're plugging in as long as you do it systematically. It could be a letter or a number. Simplify it and stop. In the previous section, we were able to graph a line because it was in slope-intercept form. The same thing when you're talking about a function. You can write it in this form, slope-intercept form. Instead of with a y, we use an f of x. It means the same thing, it's just a different notation. The f just tells me this thing is a function. So to graph this, I need to find the slope, and the slope is that number in front of the x. So that's 6. The y-intercept, well, that's going to be that negative 6, but write it as an ordered pair. So write it as 0, negative 6. We can plot the y-intercept first. That's 0, negative 6. 1, 2, 3, 4, 5, 6. That's 0, 6. 0, negative 6, that is. And then I'll have a rise of 6 and a run of 1. Since my slope is 6, I can actually rewrite that as a 6 over a 1. So that's a good trick. If you can see that it's a whole number, just put it over a 1. That's going to be our slope. So we have a rise of 6 and a run of 1. And this is going to be our line. F of x equals 6x minus 6. Let's sketch our graph. And that's it. That's our line. So it's very similar to linear notation, except we're using f of x instead of y. For the next example, f of x equals 2/7 x minus 3. Again, start with the slope. That's going to be the number in front of the x. That's 2/7. The y-intercept, that's 0, negative 3. When I graph these, I always start with that y-intercept of 0, negative 3. That's 1, 2, 3. So that's the y-intercept, 0, negative 3. We got that. Then we'll have a rise of 2 and a run of 7. So go up 1, 2, and a run of 7. 1, 2, 3, 4, 5, 6, 7. That's my second point. Then we can connect the 2 points and draw our line. Here's your chance now. You can try the next example. I want you to find the slope and the y-intercept and plot the 2 points to draw your line. The slope should be 5 over 4. And the y-intercept is 0, negative 5. To graph this, I need to start with the y-intercept first. 1, 2, 3, 4, 5. So this is the point 0, negative 5. And I need to use the rise of 5 and a run of 4. 1, 2, 3, 4, 5 as a rise and a run of 4. And this is our second point. And we just need to connect the 2 points now. That's our graph. In this example, let's refer to the graph of the function f of x, and let's find f of 2. Remember, f of x is going to give us the output. The input is the x, and the output is the value that we get from evaluating what f of x is. You could also think of this as a point. X, y, the x is the input, the y is the output. So when they're asking you find f of 2, this is the x. X equals 2, and all we need you to do is find what y is on the graph. So I look at the graph, this is x equals 2, and figure out where it intersects my graph. This is the point 2, 3. What this tells me is if I plug in a 2, the output is 3. So f of 2 is equal to 3. The input is 2, the output is 3. Or 2, 3 is on the graph. Let's try it again for part B. Part B is asking us to find a value of the letter A such that f of A gives us 9. So A is unknown. We don't know what that is. But 9, that's the y. So we are looking for the point something, 9 on the graph. So look at the graph. Where is the y coordinate 9? We're looking for that x coordinate that's missing. So if you look at it carefully, this is where the y coordinate is 9. Hey, and it crosses my graph right here at negative 2 comma 9. That's our x, that's our y. What this means is, it means f of negative 2 equals 9. So that's it. That negative 2 right there must be a. A is equal to negative 2. That's our missing variable that we need to find. A is equal to negative 2. In part C, they want to find the domain and find the range. The domain is the set of all possible inputs. Well, that's hard to understand. So I think of the domain as the set of all x values, and the range is the set of all outputs for the function. That's hard to understand for me. So I think of it as what is the y output, or what's all of the possible y values that we can actually have. So to find the domain, I look at the graph. I ask myself, how far does it go to the left? Well, if I follow the x-axis, it goes to the left forever. This graph goes forever to the left. If I go to the right, well, this arrow here goes down, but it still goes to the right forever. So the domain is negative infinity. It goes to the left forever. It goes to the right forever. That's our domain. For our range, I ask a different question. I ask, how far does the graph extend downwards? Well, it extends downwards forever towards negative infinity. And if you look at the graph, it keeps going up and up and up forever. So this graph has a range of negative infinity to infinity. It goes down forever. It goes up forever. The domain is how far left it goes to how far right it goes. So I want you to take some time and seriously think about the next example on your own. Answer these questions. Find f of negative 1. Find a value of a such that f of a equals negative 8. And then also state the domain and range. Alright, let's try it together. Now again, for part A, we are given x. I want you to find the y. So we're looking for a point on the graph that's negative 1 comma something. So if you look at negative 1 for the x and cross it with the graph, this is the point negative 1 comma 4. That's on the graph. So since negative 1 comma 4 is on the graph, that implies, since this is x, this is y, f of negative 1 equals 4. So that's it for part A. The x is the input, the y is the output, or the answer of f of negative 1. That's part A. For part B, I don't know what that x is. That's what I'm looking for. But we are given the y, which is negative 8. So look on the graph. Where is there a something comma negative 8? So the negative 8 is given. That's the y coordinate of negative 4 comma negative 8. That's on the graph. Negative 4 comma negative 8 is on the graph. So this means negative 4 comma negative 8 implies f of negative 4 equals negative 8. This is my x. This is my y. And since we're looking for f of a to give us negative 8, well, that's going to be a must be equal to negative 4. That's our missing number that we're looking for. Let's find the domain and the range. Again, the domain is the x values and the range is the y values. So for the domain, I follow the x-axis. So if you were driving on the x-axis, how far do you need to go to the left to see the entire graph? Well, it goes forever towards this direction, towards the left. So it's going to go forever towards the left, and you're going to have to go forever towards the right to see that entire graph. It extends forever. So the domain is negative infinity to infinity. And for the range, well, ask yourself, if you were driving on the y-axis, going down, how far do you have to go down to see everything? Well, you got to go down forever. If I was driving on the y-axis, How far do I have to drive to see everything? Well, I gotta go forever. So it's negative infinity to infinity. Always start with going down first and going up to find the range.